Welcome to this lesson on using Amazon EMR for machine learning-focused data transformations. In this walkthrough, we will create the required networking components, launch EMR clusters, connect to the master node, and run Hadoop, Spark, and Hive workloads. Navigate to the Amazon EMR console. And begin by selecting Create Cluster. Give your cluster a name, and keep the default EMR release version and the pre-selected components. These settings work perfectly for this demonstration. As we look at the node types, the primary node, formerly known as the master node, is responsible for coordinating the entire cluster. It runs services like the Yarn Resource Manager, the Hadoop name node, and the Spark driver in client mode. This node assigns tasks, monitors the health of the cluster, and manages all processing metadata, though it does not store HDFS data. The default instance type is fine for this walkthrough. Next, we review the core nodes, which act as long-lived workers and also provide HDFS storage. These nodes store the actual data blocks and contribute directly to the cluster's storage layer. The default settings here are also suitable for our purposes. The task nodes function purely as compute-only workers. They do not store HDFS data, but they provide additional processing power for parallel workloads such as Spark or Hive jobs. Because they hold no persistent data, task nodes can scale in and out dynamically and are excellent candidates for low-cost spot instances. With node configuration confirmed, we keep the default VPC, subnet, and security settings. The default log location is also acceptable for this cluster. Before launching, we create a new security configuration. Enter a name for your configuration, and for at-rest encryption, choose the KMS key that you created earlier. Once everything is in place, your EMR cluster is ready to be deployed. I already created a KMS key earlier, so I will reuse it for this EMR cluster. I am also selecting the PEM certificate that was created previously. Next, I specify the two S3 buckets for this cluster. One bucket is for input data. The other bucket is for output results. Before launching the EMR cluster, we must create two VPC endpoints. The first is an S3 gateway endpoint. This keeps traffic between the Hadoop cluster and S3 inside the AWS network. The second is an EC2 Instance Connect endpoint. This endpoint allows SSH access to the master node, even though the master node uses only a private IP address. Let's create the S3 gateway endpoint. Now, let's create the EC2 Instance Connect endpoint. The order does not matter. I paused earlier because these endpoints take a few minutes to become available. Once ready, the endpoint displays an IP address. This IP will be used as the source in the SSH rule for the master node. Launching the first EMR cluster. Let's return to the EMR setup and create the cluster. The cluster is now created. It may take some time before it becomes fully available. Next, I will launch a second EMR cluster by cloning one that I created earlier. On the EMR console, I select the previous cluster and choose the clone option. We can choose which applications to install. I will use the default set, Hadoop, Spark, and Hive. These are the tools needed for this exercise. For instance types, I will use m5.large for the master, core, and task nodes. These are sufficient for a demonstration. This EMR cluster runs in a private subnet. It does not receive a public IP address. We do not need an EC2 key pair because we will connect using EC2 Instance Connect. This cluster uses the security group named EMR DemoSG. Reviewing IAM roles and endpoints. Now let's verify the service role assigned to this cluster. We can also review the two VPC endpoints. The S3 gateway endpoint is associated with the route table used by the private subnet. Its access policy has not been modified, but you may restrict it further if needed. The EC2 Instance Connect endpoint is also available. The IP address shown here will be used in the SSH inbound rule for the master node. Now let's launch the cloned cluster. It has been created successfully. The cluster is now starting. Connecting to the master node. Let's identify the master node. Navigate to the EC2 dashboard and locate the primary instance. Open the security group associated with the instance. Modify the SSH inbound rule. Set the source to the IP address of the EC2 Instance Connect endpoint. Copy the endpoint IP and paste it into the SSH rule. Now let's connect to the master node. Use EC2 Instance Connect. Select Connect using private IP. Connection successful. We are now logged into the master node of the EMR cluster. Running Hadoop WordCount. Let's begin with a simple Hadoop job. We will run the WordCount application. First, confirm the S3 input and output buckets assigned to this cluster. These permissions are visible in the EMR console under the cluster details. Upload a small text file into the input bucket. This file contains text copied from a public wiki page. Return to the master node terminal. Verify the Hadoop installation. Everything looks correct. Run the word count job. The job completes successfully. Navigate to the output bucket. You will see the result files generated by Hadoop. Running Spark for ML transformations. Now, let's move to Spark. Start the Spark shell. Upload a second file into the input bucket. This file contains a CSV dataset with 4 columns: ID, height, weight, and gender. Return to the master node terminal. Restart the Spark shell to clear the screen. Now perform the ML-focused transformation steps. Read the CSV file. Encode the gender column. Cast numeric fields to double. Print the schema to verify the data types. Assemble the features into a single vector. Scale the features. Display the transformed output. This demonstrates how Spark performs pre-processing and feature extraction at scale. Running Hive on EMR. Next, let's switch to Hive. Upload a sample CSV file for the Hive table. This dataset contains 3 columns: ID, category, and price. Return to the terminal. Create a Hive table that references this CSV file. Run a select query. You will see the results returned successfully by Hive. Monitoring EMR with CloudWatch. Let's explore EMR monitoring. Open the Monitoring tab for the cluster. Here you can see CloudWatch metrics such as CPU usage, HDFS I/O metrics. You can also set CloudWatch alarms for automated alerts. If needed, attach an auto-scaling group to scale core and task nodes as workloads increase. Cleanup. This concludes the demonstration. We used Hadoop, Spark, and Hive on Amazon EMR to perform big data transformations and machine learning pre-processing. Remember to terminate the EMR clusters and delete all temporary resources. This prevents unnecessary costs.